Hi Math 34 students. This is Module 9, Example 1 on page 170. And this example is about living with parents. So it tells us a surprising number of young adults, ages 19 to 25 is how they're categorizing young adults, still live in a parent's home. A random sample by the National Institutes of Health included 2,253 men and 2,629 women in this age group. So these numbers right here are our two sample groups, right, or our sample sizes. And so these will be our N1 and N2 when we set up our data. The survey found that 986 of the men and 923 of the women lived with their parents. Is this good evidence that the different proportions of men and women live with their parents? How large is the difference between the proportions of young men and young women who live with their parents? So we're going to start by stating our hypotheses. So P1 is going to be the proportion of young men living with their parents. And I chose young men to be P1 simply because they came first in the example. You'll see you can usually choose P1 or P2 either way, but depending on which is greater and which is P1, you may end up with a negative relationship, which is fine. You would just know that was because you chose a greater value for P2. So we're going to let P2 here be the proportion of young women living with parents. And then we want to state our hypotheses. So our null hypothesis, H0, is going to be that the proportions are equal. In other words, that there's no change. Our alternative hypothesis is going to be that there is a change, right? And if we look back, they're asking, is there good evidence that the different proportions of men and women live with their parents? And they're asking about the difference. How large is the difference? So they're not saying greater than or less than. So we're going to say here P1 is not equal to P2. And you can get the not equal sign by holding down Alt or Option on your computer, depending on if you're on a PC or a Mac, and then hitting the equal sign. So in this case, because we've got our P1 and P2 defined, we can go ahead and write it in mathematical symbols for our null and alternative hypotheses. And when we type it in our calculator, it'll show up just like this. The null hypothesis is equal, and the alternative hypothesis is going to be not equal because we're simply wondering about the difference. This is a four-step process for writing hypotheses. And so now we're at step 2, which is collecting the data. So we want to go ahead and calculate the sample proportions, P1, P2, and their difference. And we use the hat on P1 and P2 to show that they come from a sample and not the whole population. On my computer, I have to go to the math type to input the hat. You might have a better way of doing it. The shortcut keys for this is called the circumflex accent, usually only work with vowels. So I'm going to indicate it kind of funny. I'm going to say P, and then I'm going to use the circumflex 1. So you'll know that that's the sample proportion. So our sample proportion from the men is 986 out of 2,253. And that calculates to be 0.4376. Our sample proportion from the women is 923 out of 2,629, and that equals 0.3511. So we see a smaller proportion of women live with their parents. Now for the difference, we just subtract the two sample proportions. So we're going to say P hat 1 minus P hat 2, and we get 0.4376 minus 0.3511, and we end up at 0.0865. So the difference in the probabilities is a little bit more than 8%. Now we want to assess the evidence and go ahead and find the z-score and the corresponding p-value. Remember, the z-score tells us how many standard deviations, and the p-value tells us the probability of the likelihood that the null hypothesis is true. So I'm going to show you how to do it on your graphing calculator. You can also use the formulas that are listed in the vocabulary at the front. And so if you like to use formulas, they are all right there for you to crank out these calculations. Okay, on the TI graphing calculator, we're going to go to the Stat button and then arrow over to Tests and then choose choice 6, the 2 proportion z-test. It's a z-test because we're dealing with the z-score, and it's 2 proportions because we're dealing with categorical data here. So now we're going to input our values into the calculator. So x1 is the number of men who live with their parents. So that's 986. And you'll recognize these numbers from when we calculated our sample proportions. N1 is the total sample size of men, so that's 2,253. X2 is the proportion, or the number of women who live with their parents. And N2 is the total number of women in the sample, so that's 2,629. And then we're going to select P1 is not equal to P2 when it asks about which hypothesis we're using for the alternative. And then we're going to highlight Calculate and press Enter. So take a minute and pause and follow along with your graphing calculator. So now we look at our results. So our result is that the z-score equals 6.1782. I rounded it a little bit. So this is pretty far from the center of the graph, right? This is over 6 standard deviations above the center of the graph, so that's quite a lot. And then our p-value is 6.5, and then it says e negative 10. Now this is on my calculator. Your calculator may have rounded to 0 because this is an extremely small number. Or you may have something slightly different. That's fine as long as you get a really, really small result. So if I translate this away from scientific notation, this would be 9 zeros in front of that 6. So this is extremely small probability. Okay, so now we need to use our p-value to make a decision. So I'm going to say the very small p-value indicates that it is unlikely that the sample data came from the population described by the null hypothesis. So what does this mean? Well, this means that this is strong evidence against the null hypothesis. So in this case, we reject the null hypothesis in favor of the alternative hypothesis. Okay, so when you got a small p-value, I'm going to type this in big letters for you. Small p-value tells you to go with alternative hypothesis. Okay, just how small does the p-value need to be, you might wonder? If you look back, we didn't say how small we needed to be, so you can assume that we are comparing to alpha equals 0.05. So we assume 95% confidence interval if no other value is given. Below are TI 8384 calculator directions. It works on the 83 plus, 84 plus. If you're on the TA 89, you can check in with me or see the videos that I posted. So again, because this is two proportions and we're looking for the z-score, it's the choice 6, the two proportion z-test. So example 2 is about calculating confidence intervals for two proportions. So part A tells us that rap music is more popular among young blacks than among young whites. A sample survey compared 634 randomly chosen black students aged 15 to 25 with 567 randomly selected white students in the same age group. It found that 368 of the black students and 130 of the white students listened to rap music every day. And it's asking us to give a 90% confidence interval for the difference between the proportions of black and white young people who listen to rap every day. So we need to first define P1 and P2. So I'm going to define P1 as a proportion of young black people who listen to rap because that comes first in the data set. Again, you could do it in either order. And then if we wanted to calculate the sample proportion, we could say P1 hat, or P hat 1, however you want to think about it, equals 368 out of 634 students who were surveyed who listened to rap. And so that would be 0.5804 is our sample proportion. And then we'll do the same thing and define P2 to be the proportion of white young people who listen to rap. And then we can calculate our sample proportions. So I'm going to do the same type of calculation. P hat 2 equals 130 out of 567 sample size. And this is 0.2293. Okay. Now, I'm going to use the TI calculator. You could use the formulas that are in the front and calculate out the confidence interval. If you use the formulas, remember to use the z-score that goes with 90%, and that's the 1.645. So on the TI calculator, we're going to go back to the stat menu and then arrow right to tests and then arrow down and choose choice B. So after all the numbers come the letters. And that's the two proportion Z interval. So now we can enter the data that we have. So X1 is going to be 368, N1 is 634, X2 is 130, and N2 is 567. So remember, the X values are the number of people in each group who listen to rap, and the N values are the total number of the sample size. Then for the confidence level, we're going to go ahead and enter 0.90 because we're looking for 90%, but we have to make sure we put it in as a decimal. And then highlight calculate and press enter. And the calculator will give you back the confidence interval, which is 0.30778 for the lower bound, all the way up to 0.39455 for the upper bound. So remember, this is the confidence for the difference in the proportions, right? So we could say we are 90% confident that the difference in proportions lies in this interval. And we could say that the population difference, or the difference in population proportions maybe, would be the better way to say it. Okay, so this is another calculation you can do by hand or on your TI calculator. Question B tells us a government survey randomly selected 6,889 female high school students and 7,028 male high school students. Of these students, 1,915 female and 3,078 males met the recommended levels of physical activity. And then it tells us the levels are quite high. So we need to give a 99% confidence interval for the difference between the proportions of all female and male high school students who meet the recommended levels of activity. So we're going to go ahead and say P1 equals proportion of male high school students. And I'm choosing males because they have a higher proportion, and that's going to give me a positive answer. If I chose females, that would be fine for females to be P1, but then my z-score and confidence values would have the negative version. So know that if you get a negative, it's just because of how you chose P1 and P2. So P1 is the proportion of male high school students who meet the recommended levels. And then if we calculate P1 hat, that's going to be 3,078 out of 7,028, and that's going to be 0.43796. Oh, and we'll put it down below. Then we're going to define P2 to be the proportion of female high school students who meet the recommended levels. And then P2 hat is going to be 1,915 out of 6,889, which is going to be 0.27798. So we can see the proportion of male high school students from this sample are higher than the proportion of female high school students in the sample. So again, I'm going to run this on the calculator. So on the TI calculator, hit the stat button to go to the stat menu, then arrow right to tests, then arrow right to choice B, which is the 2 proportion Z interval. So remember, you have to arrow all the way down to letter B, which is past the number choices. And then we're going to enter our data. So we've got X1 is 3,078 male students. N1 is the total number of male students in the sample, so that was 7,028. X2 is the number of females who met the recommended levels, so it's 1,915. N2 is the number of female students in the sample, so that's 6,889. And then our confidence level here, we want to be 99% confident, so it's going to give us a bigger interval because it's more confident. It's 0.99, and then highlight calculate and press enter. And then it gives us our confidence interval of lower bound 0.13935, upper bound 0.18062. And then if we want to summarize, we can say we are 99% confident that the population proportion lies in this interval. Okay, let's go look at example 3 on the next page. Example 3 is asking, are shoppers more likely to use credit cards for impulse purchases? And then it gives us this data that department store collected, and it asks us to estimate with 95% confidence. So 95% confidence tells us right away we can make a note that our alpha is going to be 5% or 0.05. So step 1 is asking us to state the hypotheses, and step 2 is going to have us calculate the sample proportions. So we actually need a little bit more data here. We need to know the total. So the total number of people who made impulse purchases is 13 plus 18, which is 31. And the total number of people who made planned purchases is 66. So just like in the two-way tables, you can add up the rows to get those numbers. So now in step 1, we want to state our hypotheses. So this is where we define P1. So P1 is going to be the proportion of impulse purchases who use credit cards. And P2 is going to be the proportion of planned purchases who use credit cards. And then our null hypothesis is going to be that there is no difference, so proportion 1 equals proportion 2. And our alternative hypothesis, it's just asking, is the difference statistically significant? So we don't necessarily need to know if it's greater than or less than. So we're going to say P1 is not equal to P2. So step 2, we have to collect the data. So we're going to calculate the sample proportions and their difference. Okay, so P1 hat is going to equal 13 out of 31, which as a decimal rounded to 4 places is 0.4194. P2 hat, and my notation isn't quite right. I can't put the hat over it in this typesetting program, but it's not an exponent. It should be the caret on top, or the circumflex, as they call it in language classes. So P2 hat, the sample proportion of planned purchases is 35 out of 66, and that's going to be 0.5303. And then their difference is going to be P1 hat subtract P2 hat is 0.4194 subtract 0.5303. And here, because the impulse purchases have a smaller proportion, this is a good example where we're going to get a negative difference. And notice this because P2 hat is larger than the proportion P1 hat. So you'll see where that plays out when we find our z-score. So now we're going to use the graphing calculator, or you could use the formulas on the front page to find the z-score and the corresponding p-value. So on the TI calculator, we're going to click the stat button, arrow right to test, and then this one we're going to choose choice 6, the 2 proportion z-test. So there's 2 different tests we've looked at, choice 6, which is the 2 proportion z-test, and choice B, which is the confidence interval. So now we'll enter our data. X1 is 13. That's the impulse purchases that use credit card. N1 is a total number of impulse purchases, and that's 31. X2 is the number of planned purchases that use credit card. And N2 is the total number of planned purchases, which is 66. And then we're going to enter P1 is not equal to P2 because we're just looking for a difference. And then let's see what the calculator tells us. So it gives us the z-score equals negative 1.0192. So we get a negative z-score here, which makes sense because we noticed earlier our difference was negative because our P2 hat is larger. And our probability is 0.3081. So this is a high probability. So before we saw an example that had an extremely small p-value, now our p-value is higher than that, or just kind of in the normal range. So we would need a p-value less than 0.05 to reject the null hypothesis, because we need to be 95% confident. Okay, so we do not have enough evidence against the null hypothesis. So this means we cannot reject in favor of the alternative hypothesis. So in other words, we keep the null hypothesis. Okay, you can go ahead and work on the group work in the group work assignment forum and post any questions you have there.